Welcome to the session. I am Dr. S. Anusha Kathyayani, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to discuss about the one of the interesting material which is called the cement, and what are the properties of cement and what is the famous and most widely used cement we are going to discuss in detail today. So, cement. First, what is a cement? Cement is a binder, a chemical substance, means made from the chemical substance that sets, hardens and others to other materials and which makes them to bind together. So this concrete is most widely used non-metallic material in construction of buildings, dams, bridges and highways. So in here cement is used in different mixtures, like with concrete it can be used as a concrete with a mixture of stones. So in concrete, cement is the essential bonding material which binds sands and rock. Here the binding material is cement, and the materials like rock and sand are used, and cement is also used as a binding material which results in the formation of a concrete when it mixed with the water. So the cement is generally a green or blue-gray heavy powder and find its importance as a building material. So it can be described as a material possessing or having adhesive and cohesive properties which results in the binding of materials together, which others together. So and they capable of bonding materials like stones, sand, rocks or building blocks. So it is used as a binding material which have cohesive and adhesive properties. So cement has a property of a special property which is called setting and hardening in the presence of water, which happens in the presence of water. So it is called as a hydraulic cement. So there are two types like hydraulic and non-hydraulic which have this property of setting and hardening. This is called the hydraulic cement. And the essential are the compositions of the cement are calcium and aluminium and silicates. So it is used for constructional purposes like bridges, dams, highways, buildings, and these compounds the compounds present in the cement are calcium, aluminium and silicates. So generally it has a calcium of 63% and silica around 22%, followed by aluminium 6 and iron oxide and gypsum of 1 to 4%. This is the general composition of the cement. Coming to the types of cement, there are two types based on this property like setting and hardening property. There are two types which is called hydraulic and non-hydraulic cements. Coming to the hydraulic cement, it is formed by the reaction of powdered cement with water. It is used for all type of constructions including underwater construction process. Coming to the non-hydraulic process, non-hydraulic cements they set and become adhesive due to carbonation. So this is used for various construction projects like except underwater construction, means in the water construction these non-hydraulic cements won't work. So hydraulic cement is the most commonly used cement for the construction of all the buildings, highways, roads, dams, etc. So coming to the Portland cement is a type of hydraulic cement. This we are going to discuss in detail about the Portland cement today, which is a type of hydraulic cement. Means here it is used this including even under underwater construction also we can use this type of cements. So generally the cements are classified into four types. One is natural cement and second one is Puzzolana cement and third one is slag cement, fourth one is Portland cement. So they based on the composition of the chemicals present in the cement, they are classified into four types. So coming to the natural cement, clinker is mixed with a gypsum. Here the clinker is mixed with a gypsum and clinker is nothing but the granules of the cement, and Puzzolana cement is a mixture of fly ash or calcined clay or a mixture of both which are intimately ground with a clinker and gypsum. This is called a Puzzolana cement. Coming to the slag cement, that is granulated slag is ground with cement clinker, gypsum to form a slag cement. So now the most important and most widely used cement is Portland cement. It is a combination of their chemical mixtures like calcium aluminates with small amount of gypsum. So this Portland cement is the most widely used non-metallic material for construction. It binds together the sands and rocks or the building blocks present in the materials, which binds together and forms the construction walls or dams, etc. So the name of Portland cement is used because it forms a very hardening material which resembles the rock, which is called a hard rock, which is called Portland. That's why the name Portland cement is given to this cement. Stone-like mass which resembles a Portland rock. It is a preferred choice generally for architects, engineers and constructors because of its unique properties. The primary reason because of its popularity is due to the hardening quickly, ability to harden quickly. Because of this, it is chosen it is chosen by as a preferred choice by architects, constructors and engineers. So this is the different types in Portland cement. Like Portland cement, first is gypsum. This is the gypsum and this is the clinker. So gypsum plus Portland cement clinker on pulverization gives the Portland cement. Next is the Portland cement clinker, which is a calcareous and clayey material burning. Here this is the calcareous and the clayey material. In actually this was exploded from the like open spaces which is having highly calcium content, around 66% of this composition of this material, this clay material which will have around 66%. This is nothing but the limestone. So this is mixed with a clayey material, so on burning at a specific temperature which results in the formation of a clinker. This clinker is ground and it undergoes a process, and with addition of gypsum it converts into the cement. So coming to the paste, Portland cement plus water. Oh, no sand or nothing, no rock. So only water plus cement gives rise this paste of this Portland cement. Then mortar. What is mortar? Mortar is Portland cement plus water plus sand will give. So sand plus cement plus water will give cement mortar. So next coming to the concrete, all three together with a combination of rock, crushed rocks or small granules. So Portland cement, water plus sand plus gravels. So small rocks which are called gravels, which gives the concrete. So coming to the composition of Portland cement, here it is a combination of calcium, aluminate and silicates. So the calcium oxide is a lime which is around 60 to 67% in the composition of a Portland cement. Coming to the silicon dioxide, which is the common name of silica, so it is around 17 to 25% in its composition. Then followed by aluminum oxide, which is called alumina, which is around 3 to 8% in its composition, followed by iron oxide, which is called iron oxide and which is 0.5 to 6%. 0.5 to 6% is present around, up to 6% it is present in the composition of Portland cement. So these are the major. Coming to the minor, like magnesium oxide up to 0.1 to 4%. Then sodium oxide and potassium oxide around 0.2 to both together will have 0.2 to 1.3%. Coming to the last, sulfuric anhydride or sulfuric trioxide, which is around 1 to 3% in its composition. It is the general composition of the Portland cement. So coming to, so we have known what are the composition and what are the elements present in the cement. Now we are going to see how it was going to function, how it was going to useful in its composition. We have this material, how it was going to function. We are going to see about the ingredients or the composition present in the Portland cement. So the first and foremost more high percentage, around 60 to 70% is lime, which is called calcium oxide. This is the principal constituent of cement. So this is the main component of the cement. So the excess of lime reduces the strength of cement. So if it is beyond the limit, it reduces the strength of the cement. because it makes the cement to expand and disintegrate due to quick setting. So if the more quantity is present, it expands and disintegrate. So brittle means it will break down. So this lime should not exceed beyond the 60 to 70%. Coming to the silica, it imparts strength to the cement. The next foremost is alumina. It is responsible for the setting action of the cement. So the excess of alumina makes the cement quick setting. Means it will dry and it will set quickly because of the presence of excess alumina. The next one is iron oxide FeO. It provides a color strength and hardness to the cement. So next coming to the sulfur trioxide, it presents of even in the presence of small amounts of SO3, it imparts soundness to cement. Soundness is nothing but the change in volume according to them. So even with the reaction of water, how it was changing according to the temperature. So it should not change. Means if we are taking the cement in a mold, we have to maintain different temperature. So after different temperature, it should not change its volume. Means this is called the soundness of the cement. Then gypsum, it acts as a retarding agent for quick setting of a cement. Then coming to the properties, all Portland cements are hydraulic in nature. As we know, these are two types like hydraulic and non-hydraulic. This Portland cements comes under the category of hydraulic cements. So the chemical composition of Portland cement. It is chemically defined as a finely ground mixture of silicates and aluminates of calcium of varying composition. Its approximate chemical composition is, we know it have calcium oxide, aluminum oxide and silicates, silicon trioxides. So we are going to see in what form they are going to present. Like they are chemically, it is defined as the calcium silicates and aluminum silicates of silicates and aluminates of calcium, means calcium silicates and calcium aluminates. So both are present in this composition. So we are going to see in which form it was present and in which percentage it was present in the Portland cement. So first is the dicalcium silicate. So formula is 2CaOSiO2. So here 2 calcium. Dicalcium means 2 calcium silicate SiO2. So this is around 25%. So the major is here coming to the percentage, the major present is 45. So the tricalcium silicate, tricalcium means 3 Ca compounds. So 3 calcium oxide silicates. So tricalcium silicate is present in 45. So which is the symbol for this tricalcium is C3S. So it is present in 45%, followed by tricalcium aluminate, which is represented as C3A. Here 3 calcium, here aluminate. So Si will be replaced by aluminum. Al2O3 will come into this because it is an aluminate. So it is C3A, which is around 10%. So the foremost and highest is tricalcium silicate, then followed by dicalcium silicate and followed by tricalcium aluminate. So tetracalcium aluminoferrite means here iron compound is also added, which is called 4CaO, Al2O3 and Fe2O3. This is small one. Fe2O3. So C4AF is the symbol for this because C represents the calcium, A represents the aluminium and F represents the iron, which is around 9%. So coming to next step is calcium oxide, and which is CaO, which is around 2%. So the next thing is magnesium oxide, which is symbol Mg and which is 4%. Last is the calcium sulfate CaSO4, which is around 5%. This is the chemical composition of Portland cement. Coming to the properties of cement, fineness. It is the size of the particles of the cement. The desired fineness can be achieved by adjusting the grinding of the clinker. Here it is fineness means it is the powdered form, whether the desired fineness can be achieved by adjusting the grinding of the clinker. So the final step is here the clinker is nothing but the foremost step of the cement formation, the final step of the cement formation. So the fineness of the cement can be achieved by adjusting the grindness. Means we are going to adjust the grinding nature of the clinker, we will get the fineness of the cement. Next is the soundness. Soundness is the ability of the cement to resist shrinking upon heating, upon hardening. This can be done by Lee-Chatelier test and autoclave test help determining the soundness of the cement. By doing these two tests, which is namely autoclave and Lee-Chatelier test, we can know the soundness of the cement. Then is the consistency. The consistency of the cement paste is its cement paste viscosity and the ability to flow. Means whether the consistency is good or not, we can check by the flow of the cement paste. This next is the strength. The compressive and this tensile and flexural strength of the cement is measured to assess the durability of cement for an elongated period. Means for a long period. Next is the setting time. The setting time of a cement is defined as the time required for the concrete to change from the liquid state to plastic state and then from the plastic state to solid state. Means generally when it mixed with the water, so the cement has a plasticity nature which means binding happens in the cement, then it move on to the from the liquid state to first a plastic state. So liquid state, plastic state, then this plastic state to solid state. So this is called the setting time. So after the setting time, solid state, it is called the here. This is hardening. So that is called the cement hardening. So here it is defined as the setting time is defined as the time required for the concrete to change from its liquid to plastic and plastics to solid state. So of this process or the time required for this process is called the setting time. And next property is the heat of hydration. It is the energy generated when water comes in contact with the cement. Generally, this is an exothermic reaction. Heat of hydration is a critical factor for curing concrete. Next is the loss of ignition. It is the process of measuring weight change of cement sample after it's been heated. So the loss of ignition helps indicate the adulteration of cement due to transportation or other factors. It is an indicator. We can see the loss of ignition means we can see whether cement was added with any other contaminants or compounds during the transportation or process. We can find out by the use of loss of ignition. So the next is the bulk density. It is the mass per unit of cement in a definite volume. So the bulk density of the cement can be measured by the unit of cement in a definite volume. Next is the specific gravity. It is defined as the ratio of mass of cement to the mass of the reference material, which is nothing but the water. So, what cement to the water ratio is the specific gravity. So, how now we are going to see how cement was made. Generally, rock quarries means the high rich calcium or limestone materials are blasted with explosives to get limestone, which is called calcium carbonate and clay. These raw materials are transported to crushing units and to be crushed into smaller particles. Means macromolecules or big rocks are grinded into smaller particles by transporting from the quarries to the these crushing units. The above raw materials is then mixed with additional components like silica, iron and iron ores etc. to make them the required cement type. So according to the required cement type, these limestone first the quarries are exploded with the explosive materials, then these collected into the crushing units and they are converted into the smaller ones. Then these ones mixed with the silica and iron ores, then various type of grinding mills are used to ground the above mixture. So upon the addition, they has to be grinded and the homogeneous mixture has to be obtained. Means the uniform all the addition of the silica and iron ore should be uniform all over the limestone, which is called this limestone material. So this is again moved to the kiln. So the mixture of iron and silica with the limestone is mixed properly, and this homogeneous mixture is introduced to the kiln, where the heating process happens in this kiln. So the extremely high temperature, that too at high temperature, this has to be heated. A process known as sintering, it converts the mixture into a clinker. So mixture is the limestone mixture plus iron plus silica. First limestone is grounded to smaller ones, then mixed with iron and then followed by silica. That homogeneous mixture is introduced into this clin. Then it is called a clinker. Clinker. This is called a clinker. This clinker resembles marble-sized pebbles. It is nothing but a small granule-like pebbles. Next, the clinker is cooled down and stored in silos, which is called a special tanks, and later ground into a fine powder, which is the fineness of the cement occurs in this stage with grinding mills. Then the cement is packed into different types of packaging and shipped. So this is the clinker. This is the sintering, means the high temperature was used to here to heat this. Here the this is by conveyor belts. The limestone granules are comes into this, enters into here. Then it was grinded according to the fine size. Then it was introduced into the kiln. So this kiln at high temperature, it converts the cement, this mixture into a pebble-like marbles called clinkers. Then it is cooled. Then it after heating, then it was cooled in the cooling clinkers, where they are stored in silos, and then they are grounded into very fine cement, which is what we are going to see here in the normal like building construction area. So the cement is packed in different types of packing and packaging and shipped. So the production steps generally involved are they are crushed, screened, and stockpiled. So the raw materials are in with definite proportions are obtained to obtain raw mix. They are mixed with like aluminum and this iron ores, which is called two types. They are dry and wet mixing. In the presence of water and without water, they will first mix. The prepared raw mix is fed into the rotary kiln, which will rotate with the help of sinters, and high temperature will be there in the kiln. As the material passed through the kiln, the temperature raised up to 1300 to 1600 degrees centigrade. So, starting from 200 to 300, it was raised to around 1300 to 1600 degrees centigrade. This process is called as burning. This whole process takes in the rotary kiln, means kiln which is rotating. So, this is called the burning. The output, so the obtained mixture, which is like marble sized pebbles, is called a clinker, which is around 0.15 to 5 centimeters in. These pebbles are around 0.15 to 5 centimeters in its dia. Here we can see this is the rotary kiln. Here the introduction. Here this is the kiln. So the kiln, here the obtained thing is clinker. Since the clinker is allowed to cool down in the silos, they are cooled and stored. Then it is ground with gypsum to adjust setting time. So again, the gypsum is added, which is having a high setting property. So that should be around 3 to 6%. It should be added after the formation of this clinker. So once they are mixed according to the type of the cement, the composition decides. So according to that, they are stored, and then they are grinded with the this they are grinded into very fine powders, then packing and marketing. Here we can see here temperature around 400 to 1500. So when the raw material, this is a mixture. This mixture is limestone, silicates, iron ores, depending upon the type of the cement. So it will enter into the, this is the kiln, rotary kiln. So this is mixed, and this is called homogeneous mixture. This enters into the kiln, where it was gradually heated from 450 to around 1600 degrees centigrade. Then it results in the formation of 0.5 to 5 centimeter pebble sized marbles called clinkers. Then these clinkers was added then with gypsum of 3 to 6% according to the type, then ground into a very fine powder using mills, grinding mills, which results in the formation of cement, which is packed and shipped. Then what are the reactions going to take place in the clinker? So at 100 degrees centigrade, so any water molecules present in the homogeneous mixture will get evaporated. And 150 to 350 degrees centigrade, the loosely bound water is lost from clay. So the clay will have the absorbing capacity. It have water molecules. That loosely bound water is from the clay is got evaporated. Then above 350 to 650 degrees centigrade, this decomposition of clay, it will decompose into silicon dioxide and aluminum trioxide. So again at 600 degrees centigrade, the decomposition of magnesium carbonate, which decompose into magnesium oxide and carbon dioxide. So it evaporates. The carbon dioxide evaporates. Again at 900 degrees centigrade, the decomposition of calcium carbonate, which is CaO and CO2. Here at this temperature, what happens? This carbon dioxide evaporates, and here now the mixture is from here water lost, minus H2O, here minus H2O, here silica dioxide and Al2O3 present, here magnesium oxide. Here this is minus, means it was evaporated. CO2 evaporated. Here minus CO2. Here calcium oxide. Means now the mixture is water free, carbon dioxide free, and it is only a pure mixture of aluminates and silicates followed by magnesium oxide and calcium oxide. So as it has to be proceed up to 1600 degrees centigrade. Now we are at 900 degrees centigrade. So again 1250 to 1280 degrees centigrade, the liquid formation and the start of compound formation, which is called the clinker formation. At 1280 degrees centigrade, clinkering begins. And 1400 to 1500 degrees, so the clinkering continues. And again after this 1500 degrees centigrade, it was allowed to cool down. The clinker leaves the kiln and falls into a cooler. So here the sintering, here high temperature, we can see it was rotating, so it will rotate. So here as temperature proceeds, so here we can see the color change, here maroon and red color, means as the temperature proceeds, it loses its water molecules around 300 350 degrees centigrade. From 350 to 650 900 degrees centigrade, only iron and silicates, aluminates, calcium oxide and magnesium oxide, which are converted from the calcium carbonates and magnesium carbonates to magnesium oxide and iron oxide, which leaves and carbon dioxide trace evaporates. Then it has a pure mixture. It starts from liquid formation starts at 1250 degrees centigrade, and at 1280 degrees centigrade the clinkering begins, where it is a pure mixture of calciums, aluminates, and silicates of calcium with small traces of magnesium oxide. So, again after 1500, this clinkering means zero point 0.5 to 5 centimeters particles are formed, which are called clinkers. Then, after this formation, it leaves the kiln. Means this is the kiln. This is rotating kiln. So the whole reactions from 100 to 1250 1500 degrees centigrade happened here. Heating this is the cooling kiln. Here the clinker, what happens after formation of this, then it leaves the kiln. Here we can see it leaves the kiln and it enters into the cooling kiln, where again the cooling will happen. Then it was mixed with the gypsum, which is the main cause of setting of a cement. So according to the type of cement, this proportion around 3 to 6% or 6 to 8% it was decided, and then it was mixed with the gypsum and then it was grounded into cement. So this is generally the steps involved in Portland cement preparation. So the first is quarry, which is here if we see the steps involved in the cement preparation. This is the quarry where explosives are used to get the limestone. Again it was crushed from large molecules to small molecules. It was crushed and it was introduced into the conveyor. means this is the conveyor. So the primary crushing, this is they got the material, this raw material or precursor from the quarries. It was crushed. These are the conveyor belts. Then they are vibrating screens. Means due to the vibration, the screens will pass like this. So again, they segregated according to their mass. Means smaller molecules in one plane. Again, it will go for the back crushing and pulverization. Then mixed rock storage. Then blending soils, then raw grinding ball mill. These are all processed to convert all these limestone molecules into very smaller ones. Once we got, then it was mixed with aluminates and silicates. Then homogenization, this homogenization of this silos happens. Then it was fed into the kiln, where the heating of the kiln happens from 100 to 1500 degrees centigrade. It loses its water molecules and carbon dioxide molecules and converts and contains only pure forms of aluminates and silicates of calcium and magnesium. Then it was, this is the clinker. Then it enters into, once the clinkers are formed, very small 5 centimeters diameter clinkers are formed, they are fed into the coolers. Then these are clinker cooler, that is called clinker cooler. This is clinker cooler. So once it reduces its temperature, once they are cooled down, then it was mixed with gypsum. This is gypsum storage, and here gypsum is added. Then they are combined, they are crushed, or they are mixed homogeneously into a fine mixture of powder using the ball mill. Then these are stored in the bulk storage silos. They are then transported and shipped and marketed. So this is the whole process involved from the quarry to the this shipment of this Portland cement. So this is the conveyor, and then the mixing bed, where the mixing bed involves the homogeneous mixture formation of this all grinding material. It enters to the ray mill and then filter, and then preheating will happen. Here mixing bed means this aluminate and silicates are added. Then these mills and filters are only for homogeneous mixture getting. Then it enters into the kiln where it heating happens. Then cooler, where it was cooled down. Then added to the clinker silos, where it was added with the gypsum. Then it goes into the cement mill, where it was nothing but the silos. They are stored in the silos. After adding gypsum, they are grindly powdered using the ball mills, very fine powder. Even for nanoparticle preparation, we have seen the ball mill which rotate, which have the metal balls inside a one tank. So it will rotate some rotations like 800 rotations per minute. So 800 rpm or 300 rpm was set to that ball mills. So it will rotate it due to the action, the mechanical action. It was grinded into very fine powder, and it becomes homogeneous mixture, which is added, which is the mixture of gypsum and this clinker, which results in the formation of the cement. So that cement is filled. So this is the finished product, and it was logistic. It is ready for the logistics. So this is the cement production. So this is about the cement and the composition of the Portland cement and what are the steps involved in the cement manufacture. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.